How many pictures does it have?
3.
3. That's how many orbitals it has.
Wait, is the same thing right here? The same thing there? Like what we converted.
Those orbitals and those pictures, those orbitals come from those pictures, yes. All right. How many electrons can the F sublevel hold?
14.
All right. How many pictures does it have?
7.
7. Each picture can hold how many? 2. So each picture has 2. 7 pictures times 2 is 14. All right.
Okay.
All right. How many electrons are in a 3D sublevel? Away, whatever you are. Right over here. You on my screen and I want you gone. There we go. How many electrons can a 3D sublevel hold? Does the 3 have anything to do with it?
No.
Nope, just the D. So we're only talking about a D.
10.
10 is the right answer. Okay? D has how many pictures? 5. Each picture can hold how many? 2. So 5 times 2 is 10. Okay? Which sublevel is bigger, a 4F or a 6S?
4.
Okay, tell me what tells size, energy level or sublevel? Energy level tells size. Okay, when we labeled principal, orbital, magnetic, and spin, okay, look back at your very beginning of our notes on Friday with the quantum numbers. Okay, energy level told size, right? So if energy level tells size, which thing is the energy level? Is the energy level the number or the letter? The number. Okay, this right here. Oops, these things are too fat. Okay, so this is the energy level. This is the sublevel. Why on earth are you deciding to spin? Got no time for that. Okay, that's the sublevel. So if energy level tells size, sublevel tells shape.
But isn't like the sublevel S smaller than F?
Nope, not necessarily. Just means there are more of them. So 4 and 6, 4 would be 1, 2, 3, 4. 6 would be 1, 2, 3, 4, 5, 6. So who's bigger? 6. Okay. All right. And which of the following can exist? Why or why not? Can 3F exist?
Yeah.
No.
Okay. Why not?
That's like that's the 4th letter and the other 3.
That is correct. Okay. 3, energy level 3, n equals 3, can have how many sublevels? 3. What are their names? Okay, it's only allowed 3 sublevels. Remember, an energy level, number of energy levels equals the number of the sublevels. Okay, so if you have 3 energy levels, you're allowed 3 sublevels. So their names are 3S, 3P, and 3D. So 3F cannot exist. Can 4P exist?
Yeah.
If you're in a 4, n equals 4, how many sublevels are you allowed? 4. What are their names? 4S, 4P, 4D, and 4F. Can you have 4P? Yes. Can you have 5S? Yep. If n equals 5, how many sublevels are you allowed?
5.
What's the name of the first one?
5.
So that's allowed. Okay?
So those first, like the numbers instead of the letters, can only go up 7, right?
Yep. So can 2D exist?
No.
No. Because if n equals 2, How many sublevels are you allowed? N equals 2. You're allowed 2 sublevels. What are their names? 2S and 2P. So can 2D exist? No. Questions? I don't think we're good to go on quiz on that. All right, did you finish your other homework sheet?
Yeah.
All right, let's look at that. You already have it. Yeah. We had 2 of them. Well, yeah. The other one you need. Excuse me. Yeah. Scratch that. All right, so you have, did y'all finish this one, by the way?
What is that?
That's the one that we had on Friday that we went over. Y'all finish that one?
Except for like 3 questions.
Okay. There's one that's an error that you can't do. Because I didn't draw the picture.
I got the other homework too.
I didn't see it. I already asked for that.
Because I just found it.
Anybody else absent besides Devontae and Diamond? I'm getting it, Angel. Do you have homework from Friday that I checked? Okay. So I write 0 for you. That's a great way to start the quarter. Lewis, what about you? Okay.
Yeah, we didn't do 18 through 22 with the last one.
Okay. Well, we can just go over it. So Lewis gets a 0. Angel gets a 0. Devontae found it in his fabulous filing set. All right. So we start with the one that I gave you for the weekend. All right, name the 4 quantum numbers. What are their names? What values can the principal quantum number have? 1 through 7. Really, you could have written any whole number, but we're only going to use 1 through 7. All right, what does n equals 3 mean? Third energy level. How many sublevels are there if n equals 2?
2.
And if n equals 4? Good. So then we name their names. N equals 2's names would be 2S and 2P, and n equals 4 would be named
4S, 4D, 4P, 4S.
Very good. All right. So, who would be bigger, a 2S or a 4D? 4D. Is it based on the S and the D or the 2 and the 4? Based on the 2 and the 4. All right. What's the shape of an S sublevel? Sphere. What's the shape of the P sublevel? All right. The infinity symbol you will never see on the test, and I'll call it that. Did I give you the other names? All right. There you go. Say that again, Chris. Peanut, dumbbell, or 2 loads. Those are the names you need to know for them.
2 or Z? Yeah, that's Z.
That's 2. If I want a Z, I will usually write a Z this way.
I write the line.
Yeah, I will usually do a Z that way. Yeah, it's a 2. Where was I? 10. All right, so number 10 is like the last one we did on number 7. So now that we know a little bit, let's do number 10. Can 1S exist?
Yes.
Yes. All right, 2D?
No.
No. 3F?
No.
No. 4S?
Yes.
Yes. 5P?
Yeah.
And 1P?
Yeah.
Think about it. 1P. How many sublevels are you allowed at a 1?
1.
1? What's its one name? So can 1P exist?
No.
No. All right. How many orbitals does an F sublevel have? How many pictures does F have?
7.
And how many orbitals are there? 7.
Wait.
Orbitals are pictures. Remember those graphs we drew? Or the pictures? Orbitals are pictures. So F has 7 orbitals or 7 pictures. Electrons are the number that go in the pictures. Okay? Look, you didn't bring your book bag today. You look like you're at home.
I can take this one.
I know. All right. So number 12. How many electrons can be in a D sublevel? 10. How many electrons are in the S sublevel? 2. In the P sublevel? 6. Now, 15 is the only one I told you to skip, so we haven't done. 16. How many electrons can be in the F sublevel? 14. How many electrons are in the N equals 2? Any ideas?
Oh, no. Oh, that's
All right, this is a whole energy level.
Is it 2?
Nope. You got a whole energy level. N equals 2 is an energy level. You have to include the sublevels and find the electrons. So if N equals 2, how many sublevels are there? Okay, what are their names?
2s.
So how many electrons are in S? How many are in P? So how many do we have total?
8. Oh,
Okay? So if N equals 4, you have to do the same thing. If N equals 4, how many sublevels are there?
4.
4. So what are their names?
4s, 4p, 4d, and 4l.
Yep. So how many electrons are in S? And in P? And in D? And in F? So you add all this up, you get 32.
So you got the number. So it doesn't matter what the number from the letter is. It'll always be 2, 6, 10, and 14.
Mm-hmm. Yeah, because the number in front of it just tells you the energy level.
And then what was 9?
Yeah, you skipped.
Oh, we skipped that one? Oh, so when you drew your P sublevels and you had your X, Y, and Z axis here, this one was on X, this one was on Y, and this one was on Z. How did I name these? Yep. That one was PX, that one was PY, and that one was PZ. And that's how you name them. Anything else I accidentally jumped over? Yes.
If you have 5 energy levels, would you still only use the 4?
You still only name the first four. Yes.
And like if they ask for the electrons, will it still be 32?
No. So let's say that we had to find the electrons if N equals 5. All right, how many sublevels are there? Okay. So we know we have S, P, D, F, and somebody out here, right?
Yeah.
So we know the orbitals are 1, 3, 5, 7. What do you suppose those orbitals are?
9.
Yep. How many electrons go here? Here, 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 here.
But I thought the last one didn't even count. Yeah.
Well, it's still there. We just don't give it a name because we don't have any elements on the periodic table to put electrons in it.
And why would we add it? Yeah.
It just exists. Remember, these are ground state orbitals, right? Ground state doesn't mean they can't be promoted into excited state orbitals.
So how do the orbitals fit in there? Like I get the numbers that you add up on your electrons, but I don't understand how the orbitals.
Oh, I can't draw those.
No, but like I don't get why you write those numbers. Like why would we even think about 1.5?
Oh, we're going to draw those. We're going to draw orbital notations and show where the electrons live in an atom. We're just not there yet. We're going to get there. Give it a day or so. We're just not there.
But I didn't draw those for like 7 and 18.
Hmm?
But we didn't write them for 7 and 18. We were finding electrons too.
We're going to get there. We're just not there yet. Rome wasn't built in a day. I can't teach it all in 45 minutes. We're going to get there. Huh? No, but by Friday, we'll have learned how to draw all that stuff. We're just not there yet.
How long is the unit?
We'll test sometime next week.
Oh my
And
Okay.
the unit after?
No? Yep. All right. Number 19. When we go from 3 to 2, what color do we see? What do y'all get when you read the chart?
Red.
All right, I get 656. Y'all get 656.
Yep.
So I got 6.56, which puts me in red. Everybody good with red?
Yeah.
All right. What are the three parts of Niels Bohr's model of the atom?
The rings around the nucleus are called orbitals.
Okay. The rings around it are called orbitals. They're fixed.
But
What?
The lowest ring is the lowest energy.
The lowest ring has the lowest energy. The further you are from the nucleus, the more energy you have.
the center
You
is
say it either way. Huh?
The center is the nucleus, right?
His center is the nucleus, yes. That's not actually one of his parts, but yes. All right, there's one more.
And they can't exist like in between them.
That's right. The other one is they can't exist in between. They move from one ring to the next ring and between the rings. They cannot exist between the
What
rings.
did you say about?
Now, which part was correct?
The last one, or the middle one, what did you say?
Is the one that Chris said. That the further they are from the nucleus, the more energy they have, or you could say it the way Chris did, the closest to the nucleus, the less energy. It doesn't matter how you say it. The one Caroline said. Which is what? Which one did you say, Caroline? I don't remember you said it.
The rings around the nucleus are orbitals.
Yeah.
They're fixed.
The rings around the nucleus are orbitals and they have fixed energy. All right, 21 is the one you can't answer, because I said given the Bohr model below, only I didn't draw a Bohr model. So there's no Bohr model to look at. So you can't do 21. All right, so 22. How does the speed of visible light compare to the speeds of gamma rays when both speeds are measured in a vacuum? Did I give you more than one speed? Well, yeah.
They're all the same.
Which is
3.0022.
3.00 times 10 to the 8
Meters per second.
meters per second. Yeah, they're all the same.
But I thought visible light was different from gamma rays.
Their wavelengths are different, but their speeds are the same. They all travel at the same speed in a vacuum because there's no friction. The only thing that would cause the speeds to be different is if they had friction. And in a vacuum, there's no friction. There's nothing to slow it down. All right, 23. Which color of visible light has the shortest wavelength? Okay, everybody okay with reading the chart to find violet? All right, which type of EMR has the highest frequencies? Okay, highest frequency. All right, when we read the chart, what's the relationship between wavelength and frequency?
Indirectly.
Inversely. All right, so wavelength and frequency are inversely. So if it says highest frequency, we go where? We go towards the shortest wavelength. So gamma rays will have the highest frequency. All right, when does emission of light occur? When an electron does what? Okay, that's from the excited to the ground state. And I think we've done that one. All right, and then 26, I'm just hitting some highlights. We haven't done this one. Which one has the greatest quantum leap? First of all, you got to go from what to what? To be your greatest quantum leap. All right, you want to go from the biggest jump in number. If you keep reading the question, it says emitted light. So emitted means you got to go from what to what? All right, excited to ground. So highest number to lowest number. So where do we have the biggest jump and the highest to lowest? A. Any questions on any of those I hit that we didn't do on Friday?
Okay, I have a question.
Yep.
How do you find, like, where you would find the values, like 18 and 19? 18 says in the what time you would have the end for the fruit to end.
Okay, so you're looking for the ring that has a 6, the dot on the 6, and the arrow pointing to the 2. Okay, so you're looking for outside, you got a dot on the 6, and that has a dot on the 6, and that has a dot on the 6, and it's got to have the arrow pointing to the 2. That arrow points to the 3, that points to the 2. So this arrow right here, follow it down, and it goes to 410. So remember, we take the 410 and we put the decimal between the 4 and the 1, so 4.1. Then we look down here and find on the number line where it's 4.1 falls. It falls there, which is why we said 5. Anybody else? Question on any of those? Yep. What? Honestly, I don't know if we'll get to it today. It may fall into tomorrow. But at some point, yes. Anybody else? That's a little lengthy for today, because we didn't finish all of our quantum numbers yesterday, so we may have to roll into them all. Oh, yeah, we didn't finish yesterday, or Friday. Remember? We weren't there. We're about 15 minutes shy. Alright, so any questions before we do the quiz?
No.
Alright.
Oh.
Yeah.
What is it? Which one's going from?
No.
On this.
Yeah, what we just doing? Any questions on this? No, I'm not gonna give it to you on the ball numbers. Y'all know Jack in the open. I'm asking.
So
I
you're
know.
Hey,
right.
I know, I told them, this is our best unit.
It's on
I don't think it's terrible.
It's on this.
Yeah. I know, y'all did great. Y'all should be able to do it again.
Okay, I got a question.
So what's the?
It's on this.
Yeah, you can't have your notes.
Oh, I just.
This is dumb question. What?
It's this.
I wasn't here.
I got
Did you never pass? I don't see why not. I didn't teach this on Friday. All the quantum numbers on Friday. Let's take it up. Add to your calling list of zeros.
May not be A's, but they're not
Yeah. It's like C.
Yep. There's no math. You don't have to calculate any C.
What is the quiz?
You said.
I just said this.
You said the two.
Yeah.
I actually thought.
That's 3 years.
So I don't have any questions. There's no math.
Can we take it tomorrow?
No.
Can we sign it?
No.
We didn't just sign, so. Is
No.
it 10 questions?
Huh?
How many questions?
10?
Yes, 2.
10.
This is between 2.1 and Jason.
There's no definitions. You don't have to define anything.
Really? So what?
So what are we doing?
You don't have to write any definitions.
So what are we doing?
I think I don't have any definitions.
Are we just doing?
I don't remember No, there's no definitions. Oh, there's one, but it's really, really tiny. I don't think anybody would struggle with that. It's not like some long definition. It's really short.
If I use my notes, I'm like 100.
You get a 0 for cheating. Alright, you need your blue charts. You don't even need a calculator. There's nothing to calculate. At least I don't think so.
Wait,
A quanta is a small number.
You do not have to define that. He's telling you that.
I'm gonna be amazed.
It is
what it
not that
actually
hard.
is.
Can we see our? No, one of them.
That looked pretty good. Probably supposed to look better.
Didn't you say they were gonna see it cold?
Yeah. No, that's just plain on my zipper. It's not. That's cold like out of here, but you're not going out. So you're making it up. It's your choice, we're here.
Oh, I'm. Messy.
Good. He wasn't here. He probably doesn't know Jack. He didn't do the worksheet.
Oh.
Now, in number 1, before half of you lose 5 points, there are 2 questions. And every year, people do half of the question, okay? So be sure you answer both parts. I'm asking you if you're absorbing or releasing, and I'm asking for a color. You can get your chart. I told you to get out the chart.
What color? I thought just said wait.
Oh, wavelength, sorry, wrong thing. Sorry.
What?
Yeah, what wavelength does that? Sorry, I forgot. So what wavelength, and we're still absorbing and releasing. Okay? So there's two things. Don't just answer one question.
A wavelength that's smaller than what's listed on the scale.
Okay, what now?
Can we have a wavelength that's smaller than what's listed on the scale? What scale?
Yeah, that's okay. I mean, it doesn't have to be visible light. Now, when you guys are getting wavelengths and things, they don't all have to be in the visible light spectrum, okay? So if you're like Caroline and you're like, it's not in the visible light spectrum, it's okay. Okay, because a lot of people get confused by that. Everything we did in class was visible. It does not always have to be visible, so don't panic if that happens to you,
So
okay?
does it still have next one?
It's right now. Those are in what unit? The unit's at the top of the chart. Write your number. It's in what unit? The unit's at the top in the parentheses, under the bold words. Units. Yeah. You gotta read, you gotta use those numbers and find 3 to 1 up there and find the number that goes with it. Up there behind my desk. I have to control the usage in the class.
You're asking for a definition for 3, right?
Yes, that's the only one that's the definition. And it's very short, a couple words will do it. Yeah. So using your thing, read the number off that chart. Yeah.
Can I just call these brains?
The what?
Can I call these brains so they have a specific name?
They're called energy levels. Jada, I'm assuming you don't have a note. Can be on your back there, yeah. Good to see your head. I don't know what we're actually missing at this point in this page. All right, we done? We still needs more time. You've got a minute to finish up. I might give you half the best. But you do have one of the words, so I might give you half. All right, write down whatever it is you want me to know that you know, and I'll get ready to collect. All right. You will pass first to the front, so that I can have them.
Yeah, sometimes my name's just sloppy. Like these. Oh.
No, neither are you. It's really dismissal day.
Oh, yeah.
The only day I'm here this week is Tuesday. All right. So, find your notes. Let's finish quantum theory. The quantum numbers. All right, I saved our notes from Friday so that we have what I had on the board and I can go back to it. And I just got to find them in this mess. All right, so we said there were 4 quantum numbers, right? Principal, orbital, magnetic, and spin. All right, the principal quantum number tells what? Size and energy level. All right, so, and those of you who are absent, I'm not going to go slow enough for you to write all this down, so I'm not sure you should even waste your time to try. So, if you have a first energy level, all right, n equals 1 would tell you you're in the first energy level. If n equals 3, you're in the third. If n equals 5, you're in the fifth. All right, the orbital quantum number, L, tells what 2 things? Sublevel and shape. Now, if n equals 1, n equals 1 tells you what again? You're in the first energy level. If you're in the first energy level, you are only allowed how many sublevels? 1. What is that one sublevel's name? 1s. Now, if I alter that, since I have those examples up there, if I say n equals 2, how many sublevels can you have? 2. What are their names? 2s and 2p. Okay? Now, from there, whoops, too far. We went and we talked shapes. Now, we drew the shapes of the sublevels for S and P. S can be a sphere. P can be a peanut. D, I said, was 4 lobes, and F, I said, was a flower. Now, more importantly are the number of pictures, because they lead us into the next quantum number. How many ways can we draw the S sublevel? 1. How many ways can we draw the P sublevel? 3. The D sublevel? 5. And the F sublevel? 7. Now, I'm going to jump over the next slide for a second. Okay? The magnetic quantum number is the orientation or the number of orbitals. They are directly related to the number of pictures. So, S has how many pictures? 1. So there are how many orbitals? 1. Each picture can have how many electrons? 2. So, P had how many pictures? 3. So there are how many electrons? 6. 3. Each one has 2. So 2 times 3 is 6. The D sublevel had how many pictures? 5. Each of these can hold how many electrons? 2. 2, 4, 6, 8, 10. The F sublevel has how many pictures? 7. 2, 4, 6, 8, 10, 12, 14. Now, when we were talking about in the opening, if you had, let's just say, orbital X down here, all right, it would have how many pictures? That's a jacked up axis. 1, 2, 3, 4, 5, 6, 7, 8, and 9 for its XYZ. So it could have how many electrons now in orbital X? 2, 4, 6, 8, 10, 12, 14, 16, 18. And it would continue on. What?
5?
It would what?
Is that 5 like we did before?
Yes. Yes. Okay? It's just an example of the pattern. So this would be how many different shapes or different orbitals for F. It had 7, right? So orbital, let's just say I named it X, would have how many different shapes? 9. This one would have 9 shapes. So when I get over here to the magnetic quantum number, there would be how many electrons that it could have? It would have 18. Okay? Now, It's the part that confused people on Friday because we haven't even got to the spin quantum number yet. All right, is when I brought in the numbers. The quantum numbers are not quantum letters, so we have to assign numbers to the sublevels. Okay, we're getting ready to do this. This is the part we didn't get to on Friday. We're getting ready to do that to those. Okay, those have to have numbers also. Okay, that's the downside to this. So we assign numbers to the sublevels. So when we say for S, S is a letter. It has to have a number also. So I gave you this example. All right, let's say I put in a different one. All right, I make up an address for an electron. 4, 2, 1, plus 1/2. All right, at this point, you guys should be able to tell me what these two things mean easily if you understand what's going on. All right, this stands for what?
Energy.
This is the energy level. This is the what? That's the sublevel. Okay? Now, if that's the energy level, what energy level are we talking about? N equals what? 4. So essentially, we're talking about the fourth ring. Okay? That's what that tells you about its location. Now, this is the sublevel. Now, which sublevel are we talking about? S, P, D, and F are assigned numbers. And this is where people screw up all the time. L is equal to what number for each of these? 0, 1, 2, and 3. People automatically go 1, 2, 3, 4. So when they see that 2, which one do they want to say it is? They want to say it's P. They forget that S starts at what? 0. So when I said 2, I'm actually talking about what? D. So this would be the fourth ring, and this would be the D sublevel. So you know, looking at that address, that we're in a 4D. Okay? The other two numbers we haven't learned how to find yet.
Okay, I have a question.
Yep.
So the second one is always going to be sublevel.
Always going to be the sublevel.
Okay.
Okay? This one is always going to be magnetic. And this one is always going to be spin. We just haven't talked about how to do those two yet. That's what we're getting ready to do. That's the piece we got to finish today.
So we have to know those in order?
Yes.
The principal.
They're always in that order. Principal, orbital, magnetic, and spin.
Never know these things.
All right? Everybody got it? Or as best you can at the moment. All right. So, let's finish magnetic.
Okay.
Those of you who are not here, I strongly recommend you at least go back and watch at least this part of the video on the quantum numbers. If you don't want to watch the history stuff, I don't blame you. But this part, I would at least go back and watch. Now, the magnetic quantum number has values also. Okay, M is equal to minus L to positive L. Okay, now, this is where people look at me and go, what? If y'all are already lost, this is going to send you really off your axis. What? Uh-huh.
You say
I mean really, negative L. So, our L values are these things. When I say L, that's what I'm talking about. Okay, those numbers right there. Okay? So, you have S, P, D, and F sublevels, right? S is assigned 0, P is assigned 1, D is assigned 2, and F is assigned 3. So, if we say minus 0 to positive 0, everybody in here knows that's just what?
0.
It's just 0. Okay? Now, how many different ways can we draw the orientation for an S sublevel? Just one. The only orientation an S sublevel had was this. Okay? That's what we drew. So its value is 0. That's all it has. So that number, that M equals 0, is for that orientation, that shape. Okay? That's the number that's assigned to that shape.
But where is the other picture?
Huh?
Dot?
That's the sphere that we drew back here. That's
Yeah,
just a
but
small version of it.
Where's
It's that shape.
where's M? Like I don't understand why we write M.
That's M. That's the symbol. That's the letter that's assigned for magnetic. That would be, this would be 0. That would say 0. Okay? That would be the number in the address would be 0 for that shape. Okay? So -1 to +1 would be what numbers in math class? -1, 0, and +1. So how many different shapes would we have this time? We'd have 3. So this would refer to our peanut, and our other peanut. So M would equal -1, or 0 on that one, and then +1. And again, these are just addresses. Now, for this one, M would be -2, 2, +2. So what numbers would I have here? So, how many different pictures am I going to have this time? I have 5. So this first one is -2, -1, 0, 1, and 2. Each of the pictures are assigned a number. And the last one goes from -3 to +3. So this time I have numbers of -3, -2, -1, 0, 1, 2, and 3. So -3, -2, -1, 0, 1, 2, and 3. All right, but each X, Y, and Z axis is assigned a number. Each number is an address. All right, you caught up?
So like, are they negative because they're like beneath
Nope,
on the picture?
nope. They're just arbitrarily assigned those numbers. Just like if you live on one side of 85, you're assigned to 2, and if you live on the other side, you're assigned to 5. Y'all do know I was talking about zip code, right?
Yeah.
Okay. You live on one side of business 85, you're assigned a zip code of 27292, and on the other side, you're 27295. If you're at the post office. Usually it's at the post office. You have a post office mailing address, post office box. All right, we caught up now? Yeah.
So if we have like 5, would it be -4 to 4?
Yep, it would. So if you had that X, it'd be L equals 4, -4 to 4, and you'd have 9 of those things. Okay, so if we look at the example I had a second ago, 4, 2, what I have, 1, and positive 1/2. All right, all this is, again, is that's your energy level. And I'm not going to write all this down again. That, of course, is your sub-level. And this tells your orbital. Okay? All that does is tell us that. All right? That's all that tells us is your orientation in the orbital. You can write orbital, or you can tell orientation. You can use the word orbital or orientation. That's all it tells you.
So was I wrong to write orbital of the 2? Like we have examples put in that spot, right? I wrote orbital sublevel. And then principal energy level for the first number. Here's what you have written up there. But
You have energy level
I have principal energy level and then I have orbital sublevel. Yeah.
for this one.
Yeah.
Orbital sublevel, that's the name. That's called the orbital quantum number. So if you have orbital quantum number, that's fine. Just put orbital quantum number behind it so you know that's the name of the quantum number. Okay? This is the magnetic quantum number. It tells us the orbital, or the, let me say this, the number of the orbital. It tells us which orbital. Okay, which one of the 5? Shape of the orbital. Sort of how it's oriented. Like, and I can't draw the D very well. I mean, if you use your phone, you can Google it. But it has 4 lobes, and they're rotated around the X, Y, and Z axis. But I can't draw the orientation of the D sublevel on the X, Y, and Z axis. All 4 of them look the same to me. So I have no ability to draw those on the board. Okay? And even less ability with the F. I mean, I can't even draw 1, much less 7. But if you look them up, just type in D sublevel, all of them will pop up on your phone and you can see what they all look like. But it would show you one of those for 1. Okay? But that's all that 1 means, is how it looks on that axis. That's all that number 1 is telling you, is what orientation it has. Okay? If it had -1, it would just be a different way to look at it on the axis. It would be rotated slightly different.
So it's P?
The 1, this was a D sublevel. So that 1 is going to have a 4-lobe something on that X, Y, or Z axis. If this had been a 1, then that would be a 2-lobe picture. But because that's a 2, it's going to have 4 lobes. Okay? That makes sense?
Yeah.
Okay? At least I got 2 people. All right? That's not hitting on a whole lot in a day. All right? The last quantum number. You're going to love this one. Even Lolly's going to like this one. It's not often I get Lolly to like something. All right? The spin quantum number, S. All right? Now, the downside to the spin quantum number is its symbol. Okay? Because its symbol is what? And where else have we seen S? In the sublevels, right? So if it says S quantum number, it's talking about spin. If it says S sublevel, it's not talking about spin. Okay? Now, what do you think it tells us?
The distance.
How it spins. Okay? It tells us the spin of the electron in an orbital. Okay? Now, there's only 2 electrons in an orbital, right? So, you know there's only 2 electrons in each orbital max. So, if there's only 2 electrons at each orbital maximum, do you think they spin the same direction?
No.
No, they don't. Okay? They spin
No.
in opposite directions. We call this clockwise and counterclockwise. And to illustrate clockwise and counterclockwise, we use values of positive and negative 1/2. Okay? To illustrate their values, we use positive and negative 1/2. That's all of spin.
Would clockwise be positive and counterclockwise be negative?
A lot of people make that assumption, but really it's not.
Oh my god.
It doesn't matter. You don't have to know that, okay? It's not important. All you need to know is if it says plus 1/2, it's spinning in one direction, and if it says negative 1/2, it's spinning in the opposite direction. That's all you have to know.
So I'm like, that could have been a connection, but
Yeah,
never
I'm
mind.
trying to make it too, I wrote it down and realized it.
They've not been assigned that,
Okay.
okay? All right, questions? Yes, no? All right. Let's see what we can do. All right. Y'all aren't as bad off as you think y'all are.
I'll never forget you said significant digits, and I was like, well, I'm something.
Y'all are not in as bad a shape as y'all think you are. Yeah.
Like, if there was a question, I would not.
Say what? Yeah, there's tissues right there. You didn't take a brown paper towel, did you?
No,
Thank
no,
God.
I just wanted to step out.
That's fine. Just go back there and blow your nose. All the
All
way back there by the copier. All right, let's do some easy ones, and then we'll do the harder ones right behind. All right, so these are warm up questions. These are easy ones. Okay, these should be easy. 2-3 minutes tops, and then we'll do something that's slightly harder. They're not hard. They're only slightly harder. Then I'll go back and open the opening again because they have the harder ones on the second page.
Just 2 to 3 minutes.
That was the
each.
easy one.
No, not each. Total.
Wait, what?
Oh, no.
These are the easy variety ones. I said 2 to 3 minutes, not each. Total. So your brain's frozen because it's cold in here?
Yeah.
This record says it's warm over here compared to yours, so be thankful we're over here. All right, we done? So, which quantum number tells shape? Good. If n equals 2, how many sublevels are there? What are their names? Okay. How many electrons in the d sublevel?
10.
All right. 4 is slightly harder, so maybe I'm hung you up. If n equals 3, how many electrons?
18.
All right. How do you figure that one out? Because I know some people were going to struggle with that one. All right. First of all, what is this? That's a what? That's an energy level. All right, so you got to find the electrons in the sublevels, right? So how many sublevels are there? There are 3. What are their names? So, how many in S? How many in P? And how many in D? So that'll give you 18 total. You want a shortcut?
Yes.
2n squared. That's a formula.
What?
It's a formula. 2n squared. What do you do first in math class? Exponent. So 3 squared is 9. 9 times 2 is 18.
Well, then we should learn how to do it.
I just taught it to you. You got to understand the reasons behind things. All right? Can a 1p exist?
No.
No, it cannot. Why?
Because of the 2 energy levels.
That's right. You would either need a second energy level to have 2 sublevels. All right? And how many electrons can 3p hold? 6, because p can hold how many? P can hold 6. Okay? The 3 doesn't matter. P can hold 6. 3 does not make any difference.
2, 4, 6, 10.
Huh?
Why does it not go 2, 4, 6, 10?
I don't know.
It goes 2, 6, 10, 2, 6, 10.
I'm not in charge. I'm just telling you how it works. All right. Now, these are not hard. They're just slightly harder than the ones you were doing.
Well, I will say harder.
Why is it harder?
Because these use those numbers that we were just talking about, those values, like the L values and the M values, the addresses of the electron. Okay? So what value or number, what address does the P sublevel have? Yes.
So how do you
tell-
wait,
oh,
wait, like using 3 or using what?
Because 3 would be the number of orbitals and the number of electrons. When I say value, I'm looking for a number. What's the address of the P sublevel? That's the value.
Okay.
The M value is the number assigned to the D sublevels, or the addresses of all those shapes.
The same thing?
M is minus L to positive L. That's why they're just slightly harder. They're not hard. They're just, you know,
One thing I gotta do is put what L equals.
basically.
Is that the -2, the +2 thing?
Yeah.
So we write out the values or we just write that?
Oh, we gotta write out it.
You need to give me all the numbers. Some people do not know what -2 and +2 means. I used to just let them do that at the beginning of my teaching career. You'd be surprised the answers I got when I made them write them out. Now I just don't trust anybody. I need the numbers written out. You know, I need both.
Right like that.
Yes. Was the minimum and it would need to be. I don't feel like you two are plotting against me. I'm gonna have to separate you two. You interfere for my life.
Planning on finding new elements.
That's an L for 4, right?
Okay.
That's an L.
That's an L.
What is N?
What is what?
N?
The principal quantum number N, the energy level. What's the minimum energy level you would need to have L equals 3? All right, so L is F. So what would N need to be to have an F?
4.
Is that right?
You say 4?
I guess because like.
Can you explain it?
Like the 4S, 4P, 4E, 4F.
Okay, wow.
That's correct.
I'm proud of myself.
Why?
Am I proud of myself?
No.
No. It's correct.
That doesn't work because we do it.
It asks, there's something about 4 as well.
Isn't concentrating
Because look, you remember when we, this front values of L for the orbital? And S is 0, P is 1, yeah.
Always goes
So
straight.
F is equal to 3, and F is 4, and 2, 1. It's the fourth letter, it's the fourth
I don't
letter.
think we're
So
asking.
did you do the first one? So you would need 4 energy levels.
So it would be 4D?
There would be any with 4. Because you're finding value of N. Okay.
I understand that. I understand.
All right. Have you tried them all?
Yep.
So, what's the value of the P sublevel? What number did we assign to P?
1.
1. Okay? Remember, they're not called the quantum letters. They're called the quantum numbers. So we have to assign numbers to all of them. So this is where that L equals 0, 1, 2, and 3 comes in. So that's S, P, D, and F. So P is assigned to 1. Okay? So in number 2, what's the value of the D sublevel? M value, M is equal minus L to positive L. D is 2, so minus 2 to positive 2 would be minus 2, minus 1, 0, 1, and 2. Now, what's the value of the spin quantum number? Positive and negative 1/2. Good. All right, now, if L equals 3, what's N got to be? Several of you have come up with that. If L equals 3, what sublevel are we? In order to have an F, S, P, D, F. How many sublevels is that? You've got to have a 4th energy level to have 4 sublevels. You cannot have 4 sublevels unless you have how many energy levels? 4. Okay? Now, in 5, If m equals -1 to +1, what must the value of n be? Same concept. Okay? Whoops. So, if -1 to +1, L has to be what? L is 1, P sublevel. In order to have a P, it means you have S and P. How many sublevels is that? 2 sublevels. So N has to be 2 in order to have 2 sublevels. Questions? You with me? Not with me?
I literally don't know what.
All right.
Like, I'm lost there.
I know your brains are frozen. It is cold in here. I agree.
Wow.
Maybe second period will be warmer.
It's really cold.
It was warm last week.
Yeah.
Maybe it's because it's supposed to get to 70 Wednesday and Thursday. They decided we didn't
Okay, but
need
it's not
I
right
thought we
now.
had a 1950s air system where we put on the
They control it from the central office.
Yeah, you know, they're oh,
All right. I want you to look at 12 and 13. Okay? I want you to look at 12 and 13. Yeah. I just want you to look at 12 and 13. Typically, we would do this if we'd gotten all the quantum numbers done on Friday because we wouldn't have to do the harder questions. We would have done those on Friday. All right, so look at 12 and 13. Is there a difference between 12 and 13?
No.
You sure? People get these two mixed up all the time on the quiz and the test.
Yeah, there is.
And there's a huge difference in the answer and in the question.
Don't you have to add the electrons of all the levels? Is that
For which one?
13.
For 13. Okay? This is just a sublevel. So in the F sublevel, there would be how many electrons? There would be 14 in the F sublevel. In this one, where I said n equals 4, we would have to do what? You'd have to add the sublevels. So you'd add the 4s, the 4p, the 4d, and the 4f together, and you'd get 32. Do you see the difference in the question?
Yes.
Okay. Now, we're going to do one more thing that I always hesitate to do this in classes because sometimes when I do it, students go off the deep end and then they get dependent on this chart. Here, I'll make Angel hand them out. Because they always want to look back at it and they're like, oh, I just used this to get all the answers. No, I want to try to draw connections so you see how these things all stay the same even though we've tried to piece it together. So those of you who understand how it works, this should just draw the connections a little tighter for you. Those of you who are completely lost, hopefully we can draw you out of the forest and try to get you back together with the rest of us. All right? But you cannot use this chart on anything. This is just to help you find your way.
No.
My sister's throwing.
Sorry, bang on that old man window, we had to run. Now, this woman was trying to play, she got two places.
Yeah, I think so.
All right.
We go back there.
Now, this is not a lot of space for me to write, but let's see what we can do. All right, I'm going to do the n equals 2 row. Y'all are going to do the rest of them. So if n equals 2, how many sublevels are there?
2.
What are the names of the sublevels? All right, what value is assigned to the S sublevel? This is essentially the L value.
1.
Okay, S is assigned what?
1.
0.
0. L is 0 for S. L is equal to what for P?
1.
1. And you don't have to write L equals. You can just put 0 and 1 if you want. All right. How many orbitals does the S sublevel have?
2.
Orbitals. This would be the number of axes, the number of pictures.
One.
Just has 1. How many does P have?
3.
3. All right. How many electrons can go in the S sublevel? You have 2 electrons. How many can the P sublevel have?
6.
Can have 6 electrons. Now, the M value of each sublevel. M is minus L to positive L. So, minus 0 to positive 0 is what?
0.
0. Now, that 0 is one number for one orbital. The number of numbers should correspond to the number of orbitals you have. So, minus L to positive L. Minus 1 to positive 1 is what? I have 3 numbers. I have 3 orbitals. Those things should coordinate. All right, what's the spin value?
1/2.
Positive or negative 1/2. All right,
Wait, can you explain what you said about coordinating?
the number of numbers you get here needs to match with the number of orbitals, because these numbers you get match the number of graphs or pictures you get for your orbitals. Each orbital has to have one of those numbers.
So why is that one 0 and that one?
Because how many orbitals did you have for S? Only 1, so there's only one number listed there. That 0 is that number that coordinates with that picture. That's his address, 0. Okay? There's 3 pictures here, so there's 1, 2, 3 numbers. So if you said there were 5 orbitals, there should be how many numbers listed there? There should be 5. Okay? How many electrons are in the energy level? Of 2. 2 plus 6 is 8. Now, this one we have not done. How many orbitals are in the energy level? There would be 4, because there's 1 plus 3 is 4 orbitals. Okay? I want you to do the other 3 rows. Okay? While I hand out something else. And today's your week long. Not gonna make it exact. Okay. But, so the number of orbitals in each sublevel. So how many pictures does S have? So there'd be 1 orbital.
I need one more. Which one?
Okay. Anybody else have a question? Yeah. Just a spin, plus or minus 1/2. It's the same all the way down. Spin never changes. Spin is always plus or minus 1/2. Question? Okay. Alright, gas is always gonna have 2 electrons, so it's change that to 2. Alright, so it has 2 electrons in it, that's how many will have in total 2. And then you're good. Yeah. So how many orbitals do you have here? So how many do you have total? See anything that stands out at me? Mm-hmm.
Like, I'm confused about like.
Mm-hmm. Where? Just show me the chart to the blank. M is always minus L to positive L. Okay? So you're filling in minus L to positive L. Okay? So given that, you're going to be filling in which blank we're doing. This one, your L value is 0. You're going from minus 0 to positive 0. So what do you get when you go from minus 0 to positive 0? 0. So that's your value, just 0.
Oh, we have.
You sure?
Yeah.
Okay. Yep. Yep. Yeah. Very good. Yep. Because it has 3 pictures. B has 1, 2, 3. How many pictures you got? Yep. Yeah. Mm-hmm. Yep. Yep. All right. Yes. Your homework, if you've not finished the chart, is to finish the chart. And your homework is to finish the paper. The likelihood that you will see a quiz is either tomorrow or Wednesday. Okay? Honestly, probably sometime tomorrow. Either at the beginning or end of class. Okay? So be prepared for that. Okay? What? All of the questions there, it's not like you gotta calculate anything. You read it and answer it.
Okay, what did you say the homework was on this?
All of it.
All of them.
That's what they're moaning about. You just read and answer, people.
Right, it's a lot of work. It's a lot of work.
I'll be here tomorrow. After school. I'll be here tomorrow in class. Working on it again a little bit. Any questions on homework, everything? Yeah.
I have nothing better to do.
Don't have nothing.
Yeah, we were wrong.